In 2023, NASA's Lunar Reconnaissance Orbiter, LRO, made an extraordinary discovery that would forever alter the trajectory of human space exploration. Hidden beneath the moon's barren surface lay vast networks of caves and lava tubes, formed billions of years ago during the moon's volcanic past. These natural structures offered unprecedented opportunities for future human habitation and industrial development, setting the stage for the moon to become humanity's first outpost beyond Earth. Lunar lava tubes are long, hollow tunnels formed by ancient volcanic activity. When a lava flow's surface solidifies while the molten interior continues to flow, it can leave behind these tubular voids once the lava drains away. Some of these tubes on the moon are believed to be hundreds of meters wide and extend for many kilometers. These structures, along with naturally formed caves, provide an ideal environment for establishing a permanent human presence on the moon. The moon's surface is a harsh and unforgiving environment. Temperatures swing from scorching heat during the day to extreme cold at night, with no atmosphere to protect against the constant bombardment of solar radiation and micrometeorites. However, the caves and lava tubes offer natural protection from these hazards. Shielded from the sun's radiation and temperature extremes, these subterranean spaces are the perfect candidates for building the first human habitats on the moon. Recent studies have confirmed the stability of these lunar structures. Unlike Earth's caves, which are subject to erosion and seismic activity, the moon's lava tubes have remained largely untouched for billions of years. This stability, combined with the moon's lower gravity, about 1/6 of Earth's, makes them ideal for construction. As the discovery of these lunar caves and tubes has opened new possibilities, scientists and engineers are developing emerging technologies to make lunar habitation a reality. Among these innovations, several stand out as particularly promising for supporting future generations on the moon. Development is 3D printing using in-situ resources. The moon's regolith, a layer of loose, fragmented material covering its surface, is rich in various elements, including silicon, aluminum, and titanium. NASA and other space agencies are developing 3D printing technologies that can use this regolith as a raw material to construct habitats, tools, and infrastructure directly on the moon. In-situ resource utilization, ISRU, is a critical concept for lunar habitation. Instead of transporting building materials from Earth, which is expensive and logistically challenging, ISRU allows astronauts to live off the land, using the moon's resources to build and sustain their outposts. For example, 3D printers could create habitat modules, radiation shields, and even parts for machinery, reducing the need for resupply missions from Earth. The challenges of building and maintaining a lunar base in a hostile environment necessitate the use of advanced robotics and artificial intelligence, AI. Autonomous robots controlled by AI will be essential for performing tasks that are too dangerous or time-consuming for human astronauts. These robots will be responsible for exploring and mapping the lunar caves and tubes, constructing habitats, and maintaining equipment. They will operate under the harsh conditions of the lunar surface, performing tasks with precision and efficiency. AI will allow these robots to make real-time decisions, adapt to unexpected challenges, and work collaboratively with human operators both on the moon and for mission control on Earth. Life support is another critical aspect of sustaining human life on the moon. The moon has no breathable atmosphere, so astronauts will need to rely on advanced life support systems to provide oxygen, water, and food. Closed-loop life support systems, which recycle air and water, are being developed to reduce the need for resupply missions. For example, water can be extracted from the moon's regolith, where it exists in the form of ice at the lunar poles. This water can be purified and used for drinking, food preparation, and oxygen production through electrolysis. Additionally, experiments with plant growth in lunar soil are ongoing, aiming to create sustainable food production systems on the moon. These systems would allow astronauts to grow their food, providing fresh produce and reducing dependence on Earth. With these emerging technologies, the vision of a permanent lunar settlement is becoming increasingly feasible. The first lunar base, tentatively named Moon Base Alpha, will be established within one of the largest and most stable lava tubes near the Moon's equator. The chosen lava tube for Moonbase Alpha is located in the Marius Hills region, an area rich in volcanic features. This location offers easy access to sunlight for solar power and proximity to potential water ice deposits at the lunar poles. Construction of Moonbase Alpha will begin with a series of robotic missions to prepare the site. Autonomous robots will map the interior of the lava tube, clearing debris and preparing the surface for habitat construction. Using 3D printing technology, the robots will build the first habitat modules, which will be pressurized and equipped with life support systems. The initial phase of the settlement will focus on creating a safe and livable environment for human occupants. The habitat modules will be interconnected, forming a small community within the lava tube. Each module will be equipped with radiation shields, airlocks, and advanced life support systems. Powering Moonbase Alpha is a critical challenge, given the Moon's lack of atmosphere and extreme temperature variations. Solar power is the most viable option, with solar panels installed on the surface near the entrance of the lava tube. These panels will collect sunlight during the lunar day and store energy in advanced batteries to power the base during the long lunar night. Research is also being conducted into the potential for nuclear power on the Moon. Small modular reactors, SMRs, could provide a reliable and constant power source, independent of the lunar day-night cycle. These reactors would be safely housed within the lava tube, providing energy for industrial processes, life support, and future expansion. Moonbase Alpha will serve as a hub for various industrial processes that take advantage of the Moon's unique environment. One of the most promising industries is the extraction and processing of helium-3, a rare isotope found in the lunar regolith. Helium-3 has the potential to fuel future fusion reactors, offering a clean and virtually limitless source of energy. The Moon's low gravity and vacuum environment also make it an ideal location for manufacturing processes that require high precision and purity. For example, the production of ultra-pure silicon wafers for electronics can be more efficiently conducted on the Moon, where there is no atmospheric contamination. Additionally, Moonbase Alpha will be a center for scientific research, particularly in the fields of astronomy and space science. The absence of an atmosphere makes the Moon an excellent location for telescopes and other observational instruments, allowing scientists to study the universe with unprecedented clarity. As Moonbase Alpha becomes established, plans for future expansion and the support of larger human populations will take shape. The base will serve as a prototype for additional settlements, both on the Moon and eventually on other celestial bodies like Mars. Future generations of lunar settlers will benefit from the lessons learned at Moonbase Alpha. As technology advances and more resources are harnessed from the Moon, larger and more sophisticated habitats will be constructed. These habitats will include residential areas, recreational facilities, and even educational institutions, creating a thriving lunar community. The expansion of lunar habitation will also be driven by the development of more efficient transportation systems. Reusable lunar landers and spacecraft will make travel between Earth and the Moon more affordable and frequent, allowing for a steady flow of people, supplies, and equipment. A lunar economy will emerge, driven by industries that can only exist or thrive on the Moon. Helium-3 extraction, advanced manufacturing, and space tourism are just a few examples of the economic opportunities that will arise. As the Moon becomes more integrated into the global economy, it will serve as a stepping stone for further space exploration. The Moon's strategic location will also make it a key waypoint for missions to Mars and beyond. With its lower gravity and abundance of resources, the Moon will be a natural refueling and resupply station for spacecraft venturing deeper into the solar system. The successful establishment of Moonbase Alpha will mark the beginning of a new era of exploration. It will inspire future generations to look beyond Earth and dream of what lies